Hello everyone, welcome back to my channel. I am Prachi Arora, an engineering student doing my community service by teaching Python on YouTube. So this is the lecture 17 today, and in the previous lecture we um, studied about the functions. I introduced you all to the functions. So let's revise it first of all. What is a function? A function is a block of code which only runs when it is called, and it can be called multiple times. Function helps reduce the code repetition and increases the readability. It can also return data as a result. These were the functions, and the function can be defined by a def keyword. Then we had types of function, built-in functions, module-defined function, and user-defined functions. User-defined functions are the one that we are studying right now. And then we had function arguments. What are function arguments? Arguments are the values passed to a function when it is called. They allow the functions to receive input data and perform operations using those values. Okay. So, what are the types of arguments? We had positional or required arguments, default arguments, and keyword arguments. What do they mean? Positional or required arguments mean the number and order of arguments passed in the function caller must be equal to the number and order of the parameters passed in function header. And default arguments are the predefined arguments that we define in the function header. Alright. Keyword arguments, on the other hand, are the ones where we use name of the arguments to while giving the value in the arguments in the function caller, and order can be changed in the keyword arguments because they are identifiable. At last we did the return statement that is used to end a function and send a value back to the caller. Return is very important, so understand it. It returns the value to the caller simply. Like if we write x equals to, we made a function some number in which we are adding the numbers, right? So we take x equals to some number as the function. So the value that is added and then returned will be stored in x, and then we can use the x wherever we want. Okay, so this was all about the yesterday's lecture. Let's move forward to today's lecture, and I will tell you about scope today. What is scope? Local scope and global scope. And then if we have time, we will do args and kwargs also. Okay. So let's make a new file, lecture 17.py. Done. So what is a scope first of all? The scope defines the specific region of a program where a variable is accessible. What does it define? A scope defines the specific region of a program where a variable is accessible. Okay. It is a block or the specific region of a program where a particular variable is accessible. Okay, it it dictates the visibility and lifetime of the variable. It is dictates the lifetime of variable within the source code. Variables are also categorized in two primary scopes now. What are the two primary scopes? Two primary scopes are local and global. Okay, so let's start with local first of all. Local scope or local variables. What are what do you mean by local first of all? Local is around us, right? Local variables are same. They are defined inside a function and exist only during its execution. They cannot be accessed outside the function. You understand what it means? Let me write it for you. Local variables are defined inside a function and exists only during execution. Okay? Local variables are defined inside a function and exist only during the execution of that particular function. You can't access the local variable of a function outside that function. Let's see an example. We'll take a variable. First of all, let's make a function x equals to 45. Print x. Okay, and then we do function here. So this should print 45, right? Let's run and see. See, it's printing 45. But if I want that x outside the function, if I call it outside the function, it will give us an error because x doesn't exist outside the function. See, it's giving name error. Name x is not defined. That is because it is in this function and uh, x outside the function doesn't exist. Okay, this is what you mean by global scope, local scope, sorry. This is the local scope. Let's take another example. Like if I want to take here a message, hello, and then print that message, and here I go for function and I run it, it shows me hello. See, but if I replace this print message with return message, and here I take val equals to function and print value. But if I try to print the message here directly, will it work? No, you can see already the yellow line is under it. Let's try running it. See, hello is being printed, and then we are getting a name error because message is not defined. Okay, this is how local variables work. Then we have something called global variables. What are global variables? So, global variables, unlike the local variables, are declared outside all functions and can be accessed anywhere in the program. Okay, like I give x equals to 34, then I make a diff function and I print x. Okay, then outside the function also I print x. So it will display 34 two times now. See, we didn't call the function. Yeah, now it will display two times. See, 34, 34. So, you can also say that lifetime a local variable is a function, whereas lifetime of a global variable is the whole function, the whole program. Do you understand now? When we define the local variable, when we defined x equals to 45 inside the function, its lifetime got reduced to only that function. But when we define the value outside the function, it becomes global variable and can be accessed anywhere in the program. Just like this, we defined x outside the function and it can be accessed inside the function also and outside the function too. So we have here x plus equals to 20. What will be the changes now? We have done x plus equals to 20. So answer should be 54. So let's try running it. X equals to x plus 20. Let's try running it again. So it's showing us cannot access local variable x where it is not associated with the variable value. So what we can do is changes made inside the function remains inside the function. Okay, we can make a change here. X equals to x minus 10 and then it will be changed. See, 44 and 24. So this is the global variables and local variables. Hmm. So what are the main uses of local variables? If a variable is defined both globally and locally with same name, local variables shadows the global variables inside the function. Okay, like we give two variables with the same name. So inside a function, the local variable will be given one the preference. Okay, so the changes to the local variable does not affect the global variable unless explicitly declared variable as global. How does that work? Let me show you. If we define a function again, side bit we have a variable x equals to 60 and I print 6x. Outside the function I have x equals to 20 and now I run the function and then print x. This function will print 60 because here's x equals to 60 is the local variable and it will be preference of the function to use local variable. Okay, then we have this global variable and this print function will be using this global variable. Let's try running it. See, 60 and 20. Then we have, if I modify local variable inside the function, the changes will be local too. I told you already, x plus 10. So it should print 30 in this one and it remains 20 globally, like this. It's giving the same error again, unbound local error. Why does this happen? Because Python assumes that x is a local since we try to modify it, but no local x exists before that line. So an error occurs. Now what do we do here? We declare x as global keyword and x. Then make changes in x and it will be changed here too. It will become 30 in the function too and outside the function too, like this. You can see we are having both of them as 30. Okay. Declaring x as global tells Python to use the variable from the global scope. The function adds 10 to x and the changes also persist outside the function. Okay. Now what happens with global versus local with same name? Let's do it. Let's take a equals to 1. Then we go for def f print. Let's take this a. Then we have def g a equals to 2. Print g a. Now def h global a equals to 3 and print h a. Okay, and then outside these functions let's print global a like this, and then we call the functions one by one and see if the changes are being done in, and then h this. Okay, so let's see what happens when we run this program. First of all, we get a equals to 1 here. Then it comes over to this print a equals to 1. So it should give us 1. Then it runs f. F also has global 1. It will give 1. Then what is the global? Still 1. After g, it will become 2 inside the function, and outside the function it still remains 1. And after running h, it becomes 3, and in global 2 it changes to 3 because we have used global keyword. So we should get 1112133. Let's try running it. See, 1112133. That's how it works. This was all about the scope. Okay, let's go to the next topic, that is args and kwargs. So let's remove this all. So what are args and kwargs? They are also the types of arguments, you can say. Just like we did positional arguments and all those, these are also the arguments. First of all, let's go for args. So what are args? They are called arbitrary arguments. Okay, it can contain multiple arguments and receives those a tuple of arguments. Arbitrary arguments are the arguments, kind of arguments that can contain multiple arguments and receive a tuple of those arguments. Okay, like uh, in positional or ordered, in required that we have to give the same number of arguments as specified. Inside the kwargs, we define the kwargs in the function header, args in the function header, and then we can specify as many arguments as we want to give. Let me show you a good example. Def add, and it's written with one asterisk. Okay, args. Then we have total equals to 0. Now we are going to receive a tuple and we have to add its elements. So we use for loop for I in args. Total plus equals to n plus equals to I. And outside the for loop we use return total. So outside the function we go for print add, and we give 1 2 3, print add, we can add 4 5 6 7 8. See, the number are not same even in these two lines, but when we run it like this, we are getting the answer. You can give as many numbers as you want here. Alright, so typically args are the arguments. Wait a minute. Args are the non-keyword arguments. Its syntax allows a function to accept any number of positional arguments. All passed values are collected into a tuple, which can then be accessed or iterated inside the function. This is useful when the number of arguments is not known beforehand. Alright, we can make this as multiply too. Next thing that we have is kwargs with two asterisks. And what are kwargs? They are keyword arguments. In this, the function receives a dictionary of arguments. Alright, it receives a dictionary of arguments. Let me show you an example. We will give def fun, and inside it we have to give kwargs like this. Then we iterate through the dictionary for k comma v in kwarg dot items, and we give print k comma val, and here we have to give the function a equals to a equals to 1, b equals to 2, c equals to 3. Okay, let's try running it. We will have a b b2 c3 like that. See, so the kwargs syntax allows a function to accept any number of keyword arguments. All arguments are collected into a dictionary where the argument names becomes the keys and their corresponding values become dictionary values. Okay, the thing we used kwarg items, it returns the key value pair from the dictionary, so it is easy to iterate through it. Okay, now if you say you want to use args and kwargs together, using them together can make the function accept both positional and keyword arguments as at once. So this was all about args and kwargs. The last topic of functions that we are left with is lambda function. Let me remove this and this. What is a lambda function now? Lambda functions are small anonymous functions, meaning they don't have a defined name. These are small short-lived functions used to pass simple logic to another function. And lambda functions contain only one expression. Result of that expression is returned automatically and no return keyword is needed. Okay? And it is mostly stored in a variable. For example, we need a function to find square of the number. We take sq equals to and take lambda x colon x by 2 and then I print sq inside it 4. So it should give us 16. See, this is how a lambda function works. Only a single line you can say. We haven't used any loop, any def keyword, anything at all. So what is the syntax of this? You can see here variable name first of all or function name you can say. Sq is the function name. Then we have lambda keyword, argument, x is the argument, and this is the expression. We have filter and mapping here also. Lambda function is used in many ways. Like first of all, it's used in conditional checkings inside the if else box. We give lambda x dash if x is greater than 0, else negative if x less than 0. Okay, and then next it is used in list comprehension too, like this. Let me show you. Function equals to lambda arg equals to x, and then arg into 10 for x in range 1 comma 5 For I in fun print I. Okay, let's run it. See, you're getting 10, 20, 30, 40. Lambda can be used to return multiple results also. Although a lambda can contain only one expression, it can still return multiple results by combining them into a tuple. So we have a thing called filter here also. What does filter do? This function uses a lambda expression to select elements from a list that satisfy a given condition, such as keeping only even numbers. If I have a list